Good morning. Today we'll be talking about folding endurance of paper. So first of all, you see the definition of the folding endurance. This is defined as log on the base 10 of the number of double folds required to break the paper sample under standardized conditions of load applied. So basically, it's being subjected to tension along with folding in a cyclic manner. That means first of all it's being folded on the left side, then on the right side. It's completing the one complete cycle. And in this way, we are basically applying the force also and bending it several times. And then we see after how many cycles it will be breaking. So if the number of cycles required for breaking the sample is n, so that is called as the number of double fold. And if you take the log on the base 10, it's called as the folding endurance. So you can see the formula here. F is equal to log on the base 10 of n. So F is the folding endurance and n is the number of double folds. So first question will come in mind, why to take the log of the double fold. So that is mainly because for most of the paper, number of double folds will be high, and to make it a simple number which can be remembered, we are taking the log here. Take for example, if the number of double fold is coming 100, and if we are taking the log, then log of 100 will be 2. So it will be converting to simple number. If the number of double fold required is coming, take for example, 1000, like for the currency note, and some other strong papers like the maps, then for 1000, if you are taking the log, it will be 3. So it will be converted to simple number in between 0 to 10 basically. That is the significance of taking the log and measuring the folding endurance in place of the double fold. So folding endurance is especially applicable for papers used for making some important maps which are being saved for several years, even for the hundreds and thousands of the years. You'll find some old maps are available. We require the very high strength, which should be having the high folding endurance. The another is the bank notes, currency note paper. You must have seen, basically we are folding several times and again unfolding it. It's being passed through the hands of the large number of people. So it should have the high folding endurance. And next is the archival documents. Again, the archival documents are used for very long time. So it should have the high folding endurance to have the good life, and it should not be breaking after storing for 50 or 100 years. So that's why we are required to have the very high strength in terms of the folding endurance. Then again, the another point is the what are the factors which will be affecting the folding endurance, or what are the parameters or input which will give you the highest strength of paper during manufacturing process. So first one is the basically the alignment of the fiber, direction of the fiber in relation to the folding. That means whether it's folding is being done along the machine direction or cross direction. So again, we are measuring the sample in both the direction, machine direction and cross direction. If you are taking any paper sample, we will be covering both the MD and CD direction. Because again, when we are manufacturing the paper and slurry is coming out from the head box, fibers will be aligning along the running of the machine or across the running of the machine. So along the machine runnability, it's called as the machine direction, and along the cross direction at the 90-degree, it will be called as the cross direction. Next important parameter will be the quality of the fibers. what type of fibers are coming from the hardwood, softwood, agro residue materials, grasses like bamboos, fir grass and others. So depending on the quality of the raw material, again in the softwood, we are having the different varieties like the northern Laconia pine, southern Laconia pine, spruce, and softwoods are having the maximum strength, they are having the maximum length and very good length to diameter ratio that will give you the flexibility of to the fibers, and it is termed as the coarseness of the fiber basically. So if you are having the very high length of the fiber and good length to diameter ratio that is nearly varying in between, or you can say in the range of the 100 plus minus something, so that will give you the high fiber to fiber bonding and high strength due to the hydrogen bonding here. And another third important parameter is the filler percentage. So filler, like the inorganic chemicals, they are not reacting with other chemicals, inert materials, but generally it provides the high optical brightness, high opacity, smoothness. But again, the negative point is the fillers will be interfering in between the fiber to fiber bonding and reducing the strength properties. Again, the folding endurance will be reducing due to the increase of the filler percentage. If you are increasing the filler percentage, certainly endurance will be reducing for the samples to have to balance in between the other properties like the optical properties, surface quality like smoothness, and the strength properties. So if you want to increase the holding endurance in a given quality of paper, certainly we have to decrease the filler percentage or increase the percentage of the long fibers. Then thickness of the paper is another important quality because the thickness will be directly related to the number of the fibers, is the number of the layers of the fibers. Higher is the number of the layers of fibers. With the increase of the fibers, the strength will be again increasing. Degree of refining is a very important parameter because it will give the fibers fibrillation or branching characteristic, and that will help in the good bonding. So generally, if you increase the degree of refining of fibers used in pulp slurry for paper making, it will give you the better fiber to fiber bonding strength and resulting into very good folding endurance. So you want to increase the folding endurance to a certain limit, you can increase the degree of refining. So generally, but again, if you are very high refining, it will be the very difficult to remove the water. And generally, that's why you will find normally we are not increasing the degrees are above 48 or 50. So normally we are having the in the range of 35 to 40, in which the very high strength is required if you want to increase the folding endurance. Now come to the point of the testing of the folding endurance. The equipment that is being used is called as a MIT tester for folding endurance. And the reference, that means throughout the world, all the industries and testing labs, they are following TAPI test method numbered as T511OM08. And if you see the brief procedure of the testing of the folding endurance, the first one is the test sample strips is being taken or it is cut in the smooth edge having the size of 1.5 centimeter width, and the length should be generally 15 to 20 centimeters should be enough, so that both the ends should be clamped in the upper and lower jaw of the equipment. So length should be taken sufficiently so it will be having the good clamping, and it should not be slipping while we are putting the folding force here applied on the sample. Then second one is the first press the upper clamp to compress the spring with the help of a load, as we have to apply the tension of 1 kg force or 9.8 Newton of the force on the sample strip. Then fix the sample strip in both the upper and lower jaw so that it should be tight without any slackness or distortions. Now release the load. Once we are putting the load, first of all, the spring will be compressed, and then we are fixing the sample. Then we are releasing the load, and the spring will be basically tightening. It will be expanding, and because of expanding, the tension will be applied in the sample, and the tension force will be equal to 9.8 Newton in the paper sample strip. And the fifth step will be we can fix the both the samples, one in the left side assembly of the clamp and one in the right side assembly of the clamp. That means one sample will be of the machine direction, another of the cross direction, and both the samples are placed together in the machine. So basically two readings will be coming from the left and right side of the assembly here. So one will be measuring for the machine direction, another for the cross direction. So you can see the difference between the strength coming in the machine direction and cross direction of the same paper. So first cut the sample strip lengthwise and then widthwise of the paper sample. That is given to you for the measurement. Now the next step will be fix both the samples in left and right set assembly of the clamp, and see there should not be any slackness or any one side edge should not be very tight, another loose. That means should be smoothly tightened, and it should be looking uniform for tension. If you are touching with the hand, you will find uniformly the uniform tension is there, and there should not be any slackness in the sample. Or distortion again should not be there. It should not be distorted to some angle. Otherwise, it will give you the false reading, the less value of the holding endurance will be coming. Then fix the reading at 0 at the start of the folding operation. Generally, we are having the digital meter here. So first of all, put the reading at the 0, and we are starting the test. Now start the motor by switching on both the simultaneously. Once the motor is starting, it will start the operation here. That means the sample will be folded from a given point at which it is tightened there, so it will be folding several times from the same point, still same point, or you can say the same fibers will be basically passing through the several cycles of the folding there. So the counter will start counting the double fold in the left and right display units, and at the break point, the counter will stop automatically. So when it is breaking, so already the auto sensor is there. So once the tensor is released, it will stop the counter. So reading will be stopping there only. You can note down easily the rating on both the sides, and this will give the number of double folds. And using the calculation given in the above formula, you can find the value of the folding test. So basically, the machine will be giving you the number of the double fold here, and then we have to put the equation to find the folding endurance. And the 13th step will be the samples should be standardized before the measurement by putting in an environment chamber. And this chamber should be maintained at the temperature of 25 degrees Celsius. And relative humidity is again very important. So you have to maintain the relative humidity as per the standard. It should be 50 plus minus 2. Generally, it's maintained at the 52% of the relative humidity.